Let's talk about digital volt ohm meter for just a few minutes here. This is a very, very important tool to anybody that wants to learn how to fix cars or do any kind of auto repair. And obviously, as time has gone on, this thing has become even more and more important. There's so much you can do with a DVOM or with a multimeter, whatever you want to call it, that related to diagnostics, that it's just the importance of this tool cannot be overemphasized. It cannot be. To anybody that is in a basic electrical class in automotive or anything else for that matter really needs to know how to learn to use a DVOM. Not just the automotive students here use them, but so many of the other programs in the T&I or Technology and Industry wing of Western Wyoming Community College have to learn how to use this tool. So anyway, I just want to talk about some of the common features that you find on a DVOM, and we'll get into some of these things in greater detail in some other videos. But for right now, I've got these three examples here, and these are kind of arranged in order of cost from left to right, but not necessarily features. The features kind of depend on exactly what you want to do with it. So the one over here on the left is the Fluke 87, and Fluke they make some really, really good electrical and electronic diagnostic equipment. The Fluke 87 is kind of a normal run-of-the-mill multimeter. It's capable of doing all the basic functions that you might possibly need to do. The one in the middle is the PDI 895, and this is an automotive specific multimeter. There's a few of those out there. In fact, Fluke makes one called the Fluke 88. And anyway, on this one, it has functions and features that are specific to the automotive technicians. So there's things that this meter will do that the Fluke 87 won't do, that relate just to the automobile. And then over here we have this little unit by Amperage, and this is a kind of, well, it's a very inexpensive meter. It's not bad for the cost. In fact, for what this meter probably costs brand new, this, it's not too bad. But we'll talk about some of the differences here. Now, starting out with the Fluke over here to begin with, the big dial, of course, is the main function selection switch, and we use that to select what it is exactly we want to look at. So to explain some of these symbols that you see on here, beginning over on this side, since that's where we're currently sitting with the meter off. Most of these meters are designed to read AC and DC. So they read AC voltage in amps, DC voltage in amps. Now, resistance is the same whether you're talking about AC circuits or DC circuits. So the ohm meter function is the same. But you'll notice here, the first selection, there's a V with the little sine wave symbol above it. This is volts AC. So in this mode, we're set up to read volts AC, and if you look on our display up here, you can see the little AC symbol is on, because that's what we're ready to read. Obviously, in the automotive world, we don't use that much, but there are times when we do. Specifically, if we're trying to see if an alternator is maybe letting a little bit of AC current slip out, we will use that function. The next one is volts DC, and this is volts DC because it has this little symbol up here with the solid line and the dashed line down below it. That represents DC. So when we're in the DC mode, we can measure DC voltage. I have a battery sitting right here, and if we take our black lead and hook it up to our negative post, and the red lead, and we hook it up to the positive post, we now have a reading on the meter that is volts DC. So you can see there's 12.54 volts in this battery as it's just sitting here on the workbench. When we measure voltage like this on a battery or in any other kind of a circuit where it's just sitting, nothing switched on, nothing's happening. We call this a static voltage test. So the static voltage test is called that because the battery is static. There's nothing going on. It's just sitting here. Sometimes we might refer to this as an open circuit voltage test, which essentially means the same thing. All circuits are open. There's no current flowing. The battery's not under load, and it's just sitting there. So that's what we have. So we're measuring volts. Now another feature I want to point out, and you find this on most of the better meters, is this little scale down here along the bottom. You can see there's some LCD segments here that are lit up to this point. This is the analog scale, and this is really good for seeing little blips of voltage that the meter might pick up. The meter is actually much faster than the display. So this meter can pick up voltage and current and whatever that may happen very, very quickly. And as you can imagine, in an electrical circuit, you can have little blips of voltage that can pop up all the time. Well, a lot of times you'll see them pop up on this analog display, but you won't see them pop up on this digital display here. When I say analog and digital, I'm talking about the manner in which it displays the numbers. So that's what that little bar right there is for. Now there's a 60 over here, and we'll get into that maybe in another video. That relates to the range which the meter has automatically selected. When we talk about this meter down here, we'll talk a little bit about manual ranging, but the whole topic of manual ranging takes a little bit more time than I want to take in this video. So anyway, that's DC volts. And you can see we're measuring DC volts here at the battery. Now I'm going to go ahead and disconnect this. We're going to move up to the next selection. The next selection is an MV, and then it's got the DC signal. Well, that's millivolts. And this is just a feature that you can go to if you are selecting if you want to select a small amount of volts, or you're only working with a small amount of volts. What this will give you is it will give you more spaces or more places behind the decimal point, so to the right of the decimal. If we were to hook this up to a small amount of voltage, you would see the display show that, and it would show more detail to the right of the decimal point. That's not something that every meter has a way to read millivolts, but this particular selection is just something that this meter has, or at least this is the way they set it up. Any kind of basic functions of a multimeter are pretty much the same, meaning any multimeter that can read voltage can read millivolts. It's not like you have to have this particular selection in order to do that. This is just something that they designed for this meter, so that if you're always dealing with millivolts, you can just go to that scale and just leave it there. Now, the next function here is the resistance checker, or ohm meter. Now, when we're measuring resistance is measured in ohms. And you'll see on the display it says OL, which basically means that we are currently experiencing, or we have the meter hooked up to in a way that we have infinite resistance. And it's like, well, of course, if you look over here, our leads are just sitting on the bench and they're not hooked up to anything. So of course we have infinite resistance between those two things. So if we take our leads here, let me unwind them a little bit so we can actually do something with them. I'm going to take them, I'm going to hook them to each other like that. So they're hooked up to each other. We go back and look over here. It shows we have 0.2 ohms of resistance in this connection that we have going on between our leads. That tells us we have continuity. The ohm meter on a multimeter such as this works in a way where it will actually use its own battery power, and it will send a small amount of current up the leads. So imagine going up the red lead, okay, over here down into the black lead, and then back up this way, and it will analyze the resistance based on the way that current is affected by running that path. It will calculate a value of resistance in ohms. Well, this is good for checking some things. usually, checking the resistance of components is the best thing for an ohm meter. Ohm meters are not good for checking the resistance of wiring. Okay? They will not give you an accurate display or an accurate reading of resistance in wiring, because that little teeny tiny bit of current that comes out of the meter, it might be able to make it back, and it might say something like 0.2 ohms, which is almost no resistance, but that doesn't take into account how much current has to flow through the wires you might be testing. So if you're checking current flow, or you're checking the resistance on a positive battery cable, goes down to the starter. From the positive battery cable down to the starter, it's a big fat wire. Well, that big fat wire might not have any resistance for the tiny little bit of current that flows from the meter, but it might have tons of resistance when it comes to moving, 100, 200 amps or more, really, that you're going to need in order to crank that starter. So we don't use ohms, or we don't use an ohm meter for checking resistance of wiring. We can use an ohm meter for checking continuity in the wiring, and a lot of times that might be all we really want to know is, does this wire connect to the other end of that wire? That's fine. But for checking resistance, the ohm meter is not good for that. The next function that we have here is a diode checker, and you can hear this thing is beeping because we have our leads hooked up, so I'm going to disconnect them. That's the diode check function, and this is for checking the function of a diode. A diode is a one-way electrical check valve, and this symbol here is the symbol for a diode. If a diode is allowing current to flow in two directions, it's probably bad. So this function here is good for checking diodes. We do that in the automotive world a little bit, but not that much. The next function here is for checking current. All right, this is, and in this position it's for checking AC current, and I'll show you how to do it, or what the function is for checking DC current in a minute. But for checking current, what we want to do is we want to determine how much current we're looking at. Is it a lot of current, or is it a little tiny bit of current? If you come down here to the bottom of the meter, you can see that there's multiple junctions here for our leads. Okay, well, I'm going to pull this red one out. You'll see that over here on above this lead, it's got all these different symbols. Well, this is the position for the red lead if we are doing any of these kinds of tests. So our temperature probe, voltage, ohms, diode check, we put the red lead in here. The black lead, which goes in our COM port, pretty well always goes in the COM port. There's never a time when we move that. If you look at these two ports over here, you can see we've got one that says A, okay, and that stands for amps, and then we've got this one here that says MA, and then this the Greek letter mu, A. So this is milliamps and this is microamps. Well, with these ports here, if we've got this selected on our mode switch, this is milliamps, and just the A by itself is amps. If we are going to be measuring something, let's say we're going to be measuring 4 amps, all right, then we want to put our lead here. If we are going to be measuring milliamps, which would be something less than 1,000 amps, or up to, sorry, that's wrong, 1,000 amps, something up to 1 amp, which would be 1,000 milliamps, then we would put our lead here. Okay, so with the switch in this position, for regular amps or over 1 amp, we're going to put it here. For something less than 1 amp, let's say a half an amp, 500 milliamps, 600 milliamps, whatever, we're going to go here. Now the microamps is this last selection, and under microamps, we're going to go in this slot too. Okay, now it's really important, if we are trying to measure amperage with our meter and we find that we're not getting any kind of a reading, there's a possibility we might have the leads in the wrong spot. Now some meters will prevent that or not allow you to measure amps when you've got your leads in the wrong spot. Some, including the flukes, will actually beep at you if you've got your leads mixed up. So I've got volt selected, but I'm in the amp slot. This one's not going to beep at us. If I select amps and I keep it in the volt slot, yeah, it's not going to beep at us then either. But quite often, some fluke meters will. Others will have other ways that prevent you from being able to put your leads into the wrong hole. But not all meters do. So that's something you absolutely have to pay attention to if you're trying to measure amps with a multimeter, is make sure that you have your leads in the right slots. The other thing is, because you measure amps in series, meaning you measure amps with the circuit disrupted and your meter hooked up, your leads for your meter are hooked up in the circuit in a manner that forces all the current to flow through your leads. Because we're hooked up in series, that means all the current is going to go through this meter. Well, if most meters, multimeters like this, won't read over 10 amps on the amperage scale. So the way you can tell, or the thing that you need to pay attention to, is on our slots down here, the one for the regular amps, you can see it says 10 amps max fused. So that can read up to 10 amps. This one over here for the milliamps says 400 milliamps fused. So basically, if we're reading over 400 milliamps, we're not going to want to use this slot. Okay, we're going to want to use this slot, and we're going to want to use just the regular amp selection. If you use the wrong slot, so let's say we're measuring 4 amps and we're running it through this port, then what it will do is it'll actually blow that 400 milliamp fuse, and then the meter will not work, or it will not measure amps. If we're measuring over 10 amps, then we'll blow that 10 amp fuse. So you have to be really careful when you are hooking up an ohm meter. We'll do a whole video on that so that you can see what that's like. But anyway, other functions here on our fluke meter. You can see these kind of yellow colored symbols. Okay, what those relate to is secondary functions. So up here, there's a yellow button. When we are in this millivolt slot, and you see that there's that little yellow symbol that looks like kind of like a thermometer, that's where we measure temperature. So if we push that yellow button, you can see our display goes to, it says open because we don't have a thermocouple plugged in. But then over here it says degrees Fahrenheit. We can change that by toggling this button to Celsius. But that's another function, like a secondary function, that is pretty handy, at least in the automotive world it is especially. You'll notice over here, this is a capacitor tester, so we can test capacitors. Now we go back to the amperage scales, it's got our DC symbol, and of course the DC symbol, like we said, is yellow. So if we want to measure DC amps, then we have to push that button, and then our display switches up here to DC amps. So anyway, those are some of the basic functions of the Fluke 87 meter. And most regular voltmeters are going to be a lot like that, or most multimeters are going to be very similar to this. So if you can measure DC volts on one meter, you can measure DC volts on another meter. Right? If we go over to the PDI meter, okay, our selector right here, it shows volts DC and volts AC. Well, in order to move back and forth, there's a toggle button. So now it's on volts AC. Push it again, we go back to volts DC. If we go over to this one, it gets a lot more complicated. Okay, we'll talk about that one in another video. But anyway, these are some of the basic functions of the voltmeter. Check out some of the other videos that we have that relate to how to use this thing. This is really good practice for those that are students up here, and you should certainly review all of these videos so that you can figure out how to use these meters. If you want to have any chance of being a good automotive technician, then you need to be a master of the DVOM.